So, okay, very good afternoon, okay, to all of you. Okay, today we will go to chapter number 6. So, data communication. So, today will be part 1, and tomorrow we will continue part 2. So, data communication is an important topic because we are using data communication in our daily life, and it is very important for uh, mechatronic engineers. Okay, so today part one will be quite short, so won't take a lot of time, and this will be the outline. Okay, we will be covering in chapter 6 5 subtopics. So, what is data communication? What is networks? Okay, and what are the protocols and standard involved? Open system interconnection (OSI), and maybe you are familiar with this. It is CPIP, the IP address, and also uh, transmission control protocols, okay, involved in the internet. Okay, so we will be covering all this throughout our chapter 6, and today we will be covering mostly on part 1 and part 2. Okay, what is data communication and what are the networks involved. Okay, then tomorrow we will be covering the rest. So tomorrow's part will be a bit longer, okay, compared to today. So I because I don't want to start on protocol and standard today because it is all interconnected, okay, between OSI and also TCP/IP. So better I complete this tomorrow. Okay, so today we will enter to the first subtopic of this chapter. So data communication. Okay, so the term telecommunication. So this term is quite familiar for us because we always deal with telecommunication. So when being telecommunication, we always will think it might be something related to end phone or something related to our internet data or our phone line. So it can be a lot of things, okay, which involve telecommunication. But in data communication, so we need to understand that the term telecommunication means communicate at a distance. So when communication is happening at a distance, so distance means is not like 1 kilometer or not like 1 meter or 2 meters. So it involves few kilometers or in between cities, in between countries. So that is what we call as a telecommunication because when we have telecommunication, it must have a communication, it must have a distance between the communication. Okay, so previously we have seen how transmitter and receiver works. Okay, so in between we have a medium. So the medium, the distance of the medium will be large. Okay, so when you have that kind of communication, you automatically classify it as a telecommunication. Okay, and another word that always familiar with us. So the word data. Okay, so what data means? So it refers to the information presented in whatever form is agreed upon by the parties creating and using the data. So meaning, so the data is available, okay, and the parties that involve. So either is the sender or the receiver, so must agree, and it must be understandable to both of them. So we cannot like simply send something that we ourselves don't understand, right? So, so the term here uh, agreed upon by the parties means so both sender and receiver understood and agree with the data communication. Okay, so they will be creating the data and also using the data. Using the data means so either in your own application or you want to transmit it to another place. So you are agreeing to all these conditions. Okay. So when you have all these conditions met, then the information we call it as a data. Because normally data, what we understood, so data means something, some information that is very useful for us. So another thing based on what we understand here is not only useful information, but the the sender and receiver must agree, okay, in creating and also using the data. Okay. So when you combine this, so we have this term data communications. Okay, so data communication means they are the exchange of data between two devices via some of the transmission mediums such as wire or wire cable or wireless. So nowadays we have wireless. So when it involves two devices, uh, so your handphone to your parents' handphone. So example, so two devices are involved and it is passing through a transmission medium. So we are our mobile phone is generally using a wireless, so we are not using the wired cable. So wired cable may be our house phone, okay, using the telecom line. So we call it as a wired cable. So or we can have a combine a combination or hybrid. So wired and also wireless. Okay. For example, our router in the house. So it can be wired through LAN cable to your PC or your TV, smart TV. But from the router to the internet, so it will be having, so it either wireless or it will be wired to the transmission line. Okay, so it can have a combination of a system. Okay, so I hope you understand all these terms. Okay, so there are five components involved in data communication. So the first thing, previously we have seen, so it must have a sender, it must have a receiver, it must have a medium. Okay, so this is from the previous chapter. In this chapter, we have an additional two. Okay, so normally sender will send a message to a receiver through a medium. Okay, so those time when you want to send, we don't, those time don't have a postage postage service. We don't have a Lala Move or whatever. So we want to send something from one point to another point, from sender to the receiver. So they will send a dove, they will send maybe an animal or anything, something that know the pathway. But nowadays, so we can send a message to any medium. So mostly we are using now is the internet. So internet will be the backbone of the communication. So the backbone of the communication is referred as the medium. Okay, and usually we will be using air. Okay, because everything wireless is connected through the air. So because our sky, our earth air, so it's having a lot of layers, uh, and we can utilize this for the communication purpose. Okay, so we know, so when we have a data, when we have a communication, we must have a sender, we must have a receiver, we must have a medium. So of course we need to have a message, and here we understood that we need to have a protocol. Okay, protocol to send and protocol to receive. So protocol means it's like a rule. Okay, so first press this button. Uh, then when press this button, this will be decoded. So it will be encoded. So it will have a rule. Rule means it's a sequence because everything involved with computer programming. So nowadays everything involved with computer programming. So normally computer programming will be sequential. So it will go line by line. So it will execute line one. So you cannot see your C programming jump from line one to line 20, then go back up. So it won't. It will go line by line unless you have a like a function call or interrupt in order to interrupt the flow. So similarly, the protocol is a set of rules that you must be followed. You must follow in order for the transmission to happen. So if like one rule is not met, so the transmission will not be successful. Okay, so maybe if in the sending protocol there's some error, so maybe the message cannot be sent through. So once everything okay according to the protocol, then the message will be sent to the receiver, and the receiver must have a protocol to receive. Yeah. So, for example, so let's say you want to go to a hospital. Okay, so you are injured, touch wood. So you're injured, then you want to get some medical assistance. So you are going to the hospital. So they cannot immediately treat you unless it's an emergency case. Then they can bypass this protocol. But if it's an outpatient treatment, so you need to fill in the form. They need to verify. So they need to check your ID because they don't want you to have any criminal record because nowadays a lot of things happen. Suddenly you will get a shot. Okay, someone shot you. Then you want to get a medical assistance. So it will when if they give you treatment immediately, then it can become a police case. So they need to have a protocol. They need to verify everything. So they need to inform your family. They must have someone as a uh, we call it as a saksi in Bahasa Malaysia. So witness to sign, agree, or family member must agree for certain things. Then they will give the treatment. So similar. So all the organization we have rules that we need to follow. So similarly in data communication, we have sending rule and also receiving rule. Okay, so the five components of data communication are sender, receiver, message, the medium, and also the protocol. Okay, so five components of data communication. Okay, so if we see the components, so what is message? So message is a information, and in our context we call it as a data. Okay, so to be communicated. So you want to communicate. You want to send a message, hello, to the receiver. So hello is a information we consider as a data. Okay, that we want to communicate. So it can be a text, it can be a number, it can be a picture, it can be a audio, it can be video. So nowadays the internet are very fast. So we even can do video call, okay, using our WhatsApp or other softwares, and there are no delay, even though they are in a different continent. So they can be in America, so they can be in Middle East or anywhere. You still can communicate as if like you are meeting them face to face. So the delay is very small. Okay. So the sender, so the device that sends the data message. Okay, so usually we human being will send the information to a device. Device will transmit it. Okay. So that's considered as a sender. So for example, we can have a computer, we can have a workstation, we can have a handset, so our handphone. It can be a video camera. So everything, the device that collects and transmit the information, we call it as a sender. And on the opposite side, we have a receiver. So the device that receives the message. So for example, computer, workstation, and set TV. So when you are sending something, so the receiving end will receive it. Okay. So we call it as a receiver. Then we have a medium, okay, a physical part, which by which the data travels from sender to receiver. So it can be wired or it can be using radio waves. Okay, so all these three are cables or wire. So twisted pair wire. So you can refer back to chapter number 1. So what is twisted pair? What is coaxial cable? So coaxial cable was used last time for the normal kind of a TV antenna on the roof. So we always will use stick to control it to channel it. So it will be using a coaxial cable. So nowadays we have a fiber optic cable. So even our Astro or other cable TVs, so they are using fiber optic cable. So fiber optic cable, so you need to make sure it's not bent. So it must be straight. So as long the glass inside is not broken, you can use it. And for wireless communications, so we use radio waves. Okay, so we utilize different radio waves to communicate. Okay, and the last one, protocol, a set of rules that govern data communication and represent an agreement between the communicating party. Uh, so these rules are important to govern. Govern means to control and to lead the data. Uh, so without the rule, so anyone can bypass. So anyone can get the message. So it is also to protect the data. Okay, especially if it's a confidential data. Okay, and it must represent an agreement between the communicating devices. So it must be agreed. So person one must be agree with person two in order for the communication to happen. So similarly in this case, okay, so without the protocol, two devices may be connected but not communicating. Just a person is speaking in French cannot be understood by a person who speak only Japanese. Okay, so you can see, let's say you have two-person talking. So one person is talking in French, the person don't know Japanese, and another person don't know French is speaking in Japanese. Uh, so how the communication will be? It cannot achieve anything because both person will not understand each other. Uh, so this protocol will ensure. So maybe before the person one meet with person two, so there will be a protocol says that uh, you cannot speak in your native language. You cannot speak in French or Japanese. You need to speak in English. So that is a protocol which gives the direction to the communication. Then when both of them read the instruction or the protocol, they understood that. So instead of talking in Japanese, so I need to talk in English. So then English is a universal language and it can be understood and the communication can happen. So that is the function of protocol. Okay, so data flow. So data flow can be three types. Okay, first one is simplex. Okay, so this is the simplex. So direction of data. So you have a mainframe, okay, or a server. Okay, from mainframe, so you are sending a info, and the info will appear on the monitor. So it will be only one way, workstation or the mainstream server to the monitor. So it's not coming back from the monitor. Because monitor is only to display, is not to give you any input. Okay, in this case. Okay, so that we call it as a simplex. Simplex is only one direction from the server to the node. We call it as node. We don't call it as a monitor. Because node is more easier to understand. Okay, then we have a half duplex. Okay, half duplex. So we have two stations, station one and station two. You want to communicate between two stations. So first you are sending a direction of the data at time one. So let's say from station A sent to station B, it take 5 minutes. So the message will be delivered 5 minutes. Okay. Then once completed, so the sending station already made a decision. So they will send again another information. Okay, it will reach to the receiving station. Okay, so from sending station, so it will be received by the receiving station. So it will only happen at one time. Okay, so If one time is sending, it cannot receive. It only will send until it finish. So once it finish, it will stop. Then you can start your receiving or sending other process. Okay, so I will give the example later. And we have a full duplex. So full duplex, like how you are using your WhatsApp call. Okay, so you are here in station A. uh, so the person that you are talking to in station B, so you can talk both ways. Okay, so how you can understand this? So this will be just like a monitor. Okay, like how we are getting our TV channel. So we are getting from the main station. So we are getting, so let's say you are using Astro, so you are getting the information from the Miasat satellite. So Miasat satellite will send the information to your TV, okay, or antenna and to the TV. So it will be one direction. So you won't send anything back unless there's any error code or what. So this, for simplex, it will only be a output device, okay, to receive the, to show the output. Okay. But half duplex and full duplex are very useful because you can use it to have a two direction communication. Okay, half duplex like walkie talkie. So you always see in the movie, right? So the person will take the walkie talkie, it will press, he will be talking, Roger, Roger. So you'll be talking. Once you finish talk, you will release the button. So the other person will listen, and you will press the button and send again the reply. So at one time, only one information flow can happen. So that is what we call as a half duplex. Then full duplex is like the example I give, the video call. So you can have communication in both ways. Okay, both person talking, both person exchanging information. So these are the information that we can have regarding the data flow. Okay, so it can be represented with simplex, half duplex, and full duplex. Okay, then networks. Okay, so we entered to the second subtopic. So when you are using a wired setup or a wireless setup, uh, we usually will have a network. Okay, network meaning you have a few computers or few devices connected together to communicate among the network. Okay, so a network is a set of devices often refer in network. We always call, we don't call it as a devices, we call it as a nodes. Okay, node A, node B, node C, node 3, node 4. So it will be like that. So easier to see. Okay, okay, so it will become connected by a communication link. Okay, so a node can be a computer, can be a printer, or any other devices capable of sending or receiving data generated by other nodes on the network. So it can be anything. A node. So maybe we are familiar with network printers. Okay, nowadays. So because we are connected in a local area network, okay, inside the building or inside your campus or inside your hostel, it is connected to the local area network. So the internet in the building. Uh, so one can be added. Okay, so it can be a computer, it can be a printer. So when you have a network printer, so whoever in the network, okay, that doesn't matter where he is, as long he is connected to the network wirelessly or through wire, so he can use this network printer. From his room, he can send a printing signal, so it will be sent to the printer, and the printer will start to print. Okay, so similar like computer or any other device. Okay, okay, so we can have two types of connections. So first, we call it as a point to point. Okay, so point one to point two. So we call it as a P2P, P2P, or point to point. Okay, point to point. So we can see you have two stations. So you have a link. So it can be a wired fiber optic cable or LAN cable. So it's connected between station 1 to station 2. Okay, or we can have a multi-point. Okay, so you can have a main frame. So you have a link here, and all are connected to the backbone. Okay, so maybe in this case, so you go and tell your friends who come and join this company, so you can get a better salary. So your friend come and join, and they will make it like this. Okay, so you will be at the back, so leading them since they are new. Okay, so I already explained this. So example of point to point is satellite link. Okay, because it must be a personal. So it cannot be like a general, like everyone can read the information. Uh, for point to point, it's more secure, more privacy. Uh, so it will be so other people cannot really read whatever information that you are getting. So you need to ensure that you have a good privacy in data communication. Okay, so point to point will ensure that uh, you can have a reserved transmission between the two devices, and no one can find out what information you're sending. So example, satellite link, change the TV channel by infrared remote control. So all these are very specific. So if point to point, if this part is PC and this part is printer, so it must be the communication must happen between them. So the communication cannot go out to other devices. Okay, so that's what we call as a point to point. And multi point, more than two devices share a single link. So like how we are doing now, so it's a multi point. So I just give you a single link of Google Meet, and all of us are connected from various points. So that is what we call as a multi point. And it is also a point to point, because only those who are in the Google Classroom can join the link, because it's created for you to do classes outdoor. Uh, so as we can see, it can be hybridized. So it can be some part can be P2P, some part can be multi-point. Okay, so it will join together. Okay, so there's a term called topology. Topology is the shape of the network. Okay, we call it as a topology. Topology meaning a standard pattern. Okay, a standard pattern that is available. Okay, so very common topology is mesh topology, is star topology, bus topology, and also ring topology. So all these four names are based on your your criteria. Okay, so how you want it to be. Okay, so it can be a mesh, it can be a star, it can be a bus, it can be a ring, and whatever. So there are many other some more, because this field is keep on evolving. So people are coming out with the best solution possible. Okay, so you can see how the ring. Maybe I show, so you can see this is the ring, and this is the ring. Sorry, this it's not. So ring is here. Okay, ring is here. Okay, so you can refer this as a ring topology. So all the PCs are connected in a string, in a network, same network cable. Okay, so we call it as a ring. Then we have local connected network topology. So uh, all the fully connected. So fully connected is like this. So all the node will be connected to all the other nodes. Okay, like you can see here. So it's connected to this, it's connected to this, it's connected to this, connected to this, and it's connected to this. So all the nodes will be interconnected. Okay, then we have star. Uh, Star is like this. Okay, so all the nodes are connected to the central hub. Okay, so central hub will control all the information. Okay, then we have line. We have a tree. So all these are not having examples here. Uh, then all the other types. So usually we will use this form, and it also can be extended to other types of topology. Okay, so this is the fully connected mesh topology. So you can see, so session 1 is connected to uh, this this station, and is connected to this station, is connected to this station, and is connected to this station. So every device in mesh has a point to point link to every other device. So why we need to have this point to point? Because at times you no need to give all the information to others. So you only, let's say this person only want to meet this person. So you, whatever thing that you want to discuss, you no need to tell, communicate to the other stations. Okay. So mesh network, it has n number of nodes, and this is the formula. Okay, n times with 2n 2n sorry n 2 n minus 1 n minus 1 n minus 1 over 2. Okay, so that's the formula. So let's say this case. So what is the number of n for this case? So anyone can give a try. What is n for this case?
Is it 5?
Yeah, 5. Yeah. So because n is the number of nodes. So you have node 1, node 2, node 3, node 4, node 5. So 5. So you substitute in this formula. So what you will get?
Uh, 10.
10. So 5 times with, so 5 minus 1 is 4. So 5 times 4 is 20. 20 divided by 2. So you can see it will have, so let's say from this station 1, 2, 3, 4. From this station, so you cannot count this already. So you need to count fresh 2. So you need to do for all this, and you will find out that there will be 10 lines or 10 duplex mode links attached to this. So don't get confused thinking this look like a star. Okay, so even though it look like a star, this is not a star topology. So this is a ring topology. Okay, so another example. Okay, then we have a star topology. So for this case, so we have 4 stations. Station 1, 2, 3, and 4. So it's connected to the hub. Okay, so it is some sort like our server. Okay, so it is connected to the up or server. Okay, so this is the example of star topology. So similarly, so it will be connected to the middle. Okay, and all the nodes will be connected to this PC. Okay, so we have some read up. Star each device as a point-to-point link only to central controller, usually okay. So usually in our labs, okay, in Unimap, so we have all the devices connected point to point, and only the main thing will be using other setup. Okay, so the devices are not directly linked to one another. So the star topology does not acquire direct traffic between devices. Okay, so you no need to, you can do it in the car itself. Okay, so up acts as an exchanger. If one device want to send data to another, it send the data to the controller, which team relay the deploy to be conveyed. Okay, wait a minute. Okay, so if okay, so you can see here, up acts as an exchanger. Exchanger meaning when you are sending data, it will receive and it will send to the receiver, and it can relay the data to the other connected device. Okay, so star topology is less expensive than a mesh topology, because mesh topology you have more link. So if you see the topology is having more link, that means it can be expensive. So there are many lesser expensive uh, methods that is available. So other advantages include robustness, because if one link fails, only that link is affected and the other links remain active. So like yeah, so let's say this PC is spoiled, this link is affected. So the other four still will be okay. Okay. One big disadvantage of the star topology is the dependency of the whole topology on one single point of up, because if the up goes down and the whole system is dead. So in this case, so we know if only one of the node is spoiled, the other four still can be used. But if the middle one is spoiled, all the connected ones will be spoiled. Okay, so that is one big disadvantage of the system. The star topology is used in a local area network. So I think you are familiar with this LAN, a local area network. So inside your building, so inside or a small area, so we call it as a local area. So network inside the local area is called the local area network. So all our PC, all our laptops, phone, all are connected to local area network. So maybe from our side to the system is local area network. After that, it may be other type of thing. So that is on the management level. Okay, so then we have a bus topology. So bus topology is like this. So we this example for three station. So let's say this is your starting point, this is your ending point. So in between you have a drop line. So it's like a socket. So all are connected. So when you plug this, then you can use this workstation. When you plug this, you can continue this workstation. It's some sort like a round light connected on our building wall. The small light. So if one light spoil, so you can just replace this, and this is like a connector. Okay, so bus is actually a multi-point. So because you can have more points. Okay, one long cable acts as a backbone to uh, to link all the devices in the network. So you can see there's a long cable from sender to the receiver. Okay, so there is limit on the number of tabs that can support and the distance between uh, those tabs, because as the signal travels along with backbone, some of the energy is transmitted into it. Okay, so I think we have studied this in thermo. When the system is doing something, so the remaining excess energy will be converted into heat energy. Okay, an advantage is the easy installation. Okay, so it's easy to install, and disadvantage is difficult reconnection and fault identification. So you need to test one by one to find out which part is faulty, because all are connected to this. So you need to have a mechanism to detect which one will be okay. Okay, then we have a ring topology. So you can see, you can see it's connected. Okay, so this is like a ring. Okay, so it's a oval shape. All are connected. Okay, so easy to install and configure. Okay, so just put the cable. So connect all the nodes, computers to the cable. So done. Okay, so you already can use it. So a disadvantage is unidirectional traffic. So it only can go clockwise or anti-clockwise. Okay, so then this is a hybrid topology. Hybrid topology means it's a combination, the combination of two or three previously discussed topology. So we have four topology. Maybe you can combine together to form a new hybrid. Hybrid means it's mix, campuran. Okay, so you have a star backbone. Okay, you have a star, backbone with three buses network. Okay, so this is the three buses network. Okay, so hybrid main star topology with each brand connecting several stations in a bus topology. Okay, so we I think we are familiar with this. So we call it we won't call it as a hub because it's connected to 12 computers. So we always call it as maybe server. Okay, maybe server or workstation. Okay, so that's the main place you will get internet. So internet will be connected to the main app, and from main app, so you tarik. Okay, so you can connect it based on the app size. Okay, so if the app is only having 10 ports, so you only can use maximum 10 of your workstation. You cannot decide this, then you buy. You need to buy first. Okay, you need to buy and understand first, or go through the data sheet before you buy, and you confirm which one you want to buy. Okay, so LAN is local area network, usually privately owned, and links the devices is in a single office, a building or campus. So it is privately owned. Okay, so let's say like Unimap. So Unimap is privately owned. So we have a management that run the university. So we consider it as a privately owned and links the device in a single office building the campus. So we in Unimap we have DMDC to manage all the internet things. So they will set where they want to put the router. So mostly now you can get Unimap Wi-Fi. So Unimap Wi-Fi. So they already fix all the devices in a buildings, uh, in a voice. So it can be this link of devices can be as simple as two PC and one printer in office, and can include audio and any video. Okay, so you can include a limited to a few kilometer. So normally the LAN we won't serve it to uh, very far distance. Usually it will be within a building, within a small compound. Okay, so it cannot like really travel until a lot of kilometers, like let's say 100 kilometers or 200 kilometers. It's not possible because it usually will have limitations. Okay, designed to allow resources to be shared between PC, the resources to be shared on uh, uh, sorry, the resources can be shared, uh, can be include hardware, for example printer, software or data. So we can have all this. So that's why in a network, so we also can find some of the PC. So let's say you don't have a you only have PC, you don't have a printer, but your friend is having a printer and he is connected to the same LAN and he made the printer available. So you can print from your laptop using his printer. You just need to select when you print the network printer, then you can select and print. Okay, there's another term called as WAN. Okay, so WAN earlier was local area network, LAN. So this is wide area network, WAN. Okay, we call it as a WAN. So what is WAN? So you can see, so this all this yellow, small universities or small office. Okay, so maybe so let's say you are having, so one node is um, maybe Unimap. So one more node can be UITM. So one more node is MRSM. Okay, all like nearby. So nearby. So one more node is QIPS. Yeah, what else are nearby? Maybe Polytechnic. So all will be having a separate local area network, but it can be interconnected using a switch one, uh, cables, cables or any connection to interconnect, and you can have another set of inputs. So A, B, and C. So these are the nodes that can you can just connect it. So by connecting, let's say you are connecting this node, node A. So you connecting to this one. So through your local area network. So this the local area network. Through the local area network, you can even access the networks, other networks that is connected to your wide area network. But of course, as I say, we need to have a protocol. You need to get the permission to use. You cannot like simply just go to other people's place. So usually they must allow you to enter first. Allow you to enter first, then they must allow you to share information with you. Okay, so you can connect uh, as many nodes possible. Okay, then we have a point to point one. So one also can have a point to point. So it's a combination. Let's say you have a computer, and then you connect it through a modem. So you have a point to point one. So it's connected to the modem or internet service provider. We call it as a point to point. Point to point are more dedicated, more specific between this node and this node. So you cannot have public access, other people to access. Okay, so we can see internet nowadays. So we are using internet. So internet is a communication system that has brought a wealth of information to our fingertips and organize it for our use. So internet is like a very big backbone for the data communication nowadays because it connects so many LAN and also WAN, okay, together. So you can get a lot of informations, okay, by just searching. Okay, nowadays, so it's going more advanced. So you can access because the information is available in the internet for so many years. So now we have like AI operated algorithms like ChatGPT, so which can collect a lot of information from a lot of places. What ChatGPT is actually doing, so it will go and search other WAN other ones uh, um, for information. So once it capture, it will write for you, okay, in a written form. So what are the findings? So when you are using ChatGPT, you need to also know the information. So you cannot like simply take and use it. Sometimes it might not be accurate because it's just like copying from elsewhere, other website. So the plagiarism will be very high. Okay, when you check it. Okay, so usually you'll have ISP. So the term ISP. So usually, if you are installing internet in the house, so you always need to go deal with the ISP. So ISP usually will be like let's say you are using Unify. So Unify Telecom TM will be your internet service provider. So if you are using Maxis, so Maxis is your ISP. You are using Celcom, Celcom is your ISP. Then it will be connected to network access point. Uh, so you can see, so ISP, it can be in uh, a just like a node. Then it will be connected to regional ISP. So meaning all the nodes in that region will be connected to the regional ISP, and regional ISP it will collect with the other regions, and it will form a national ISP. Then network access point is connecting few national ISP, a few countries. So let's say here, so maybe this is Malaysia. So all this, so regional maybe northern region, or uh, maybe based on states. So all the nodes, all the information will be passed to the regional ISP. The regional ISP will pass to national ISP, and if it's accessible, it can be shared in your network access point. So network access point is combination or connection between various national ISP. Okay, so in this world, we have almost like 200 countries. So if the 200 countries are using internet, So it will have 200 plus network files or networks that will be available to be interconnected. Okay, so I just stop with this. So we will continue the rest tomorrow. Okay, so it's just like overview for you about data communication. So tomorrow we will be covering more on the other three: protocol and standards, open system interconnection (OSI), and transmission control protocol, internetworking protocol (TCP/IP). Okay, so any question?
Doctor,
Yeah,
what about my question in group?
yeah.
What about my assignment question in group?
No, no. I'm asking about this first.
No.
Okay. So any question regarding our lecture today? No question. Okay. So if no question, so let me stop.